Hello, assalamu alaikum. My name is MD Azrof Rafid, and we are from Group 8, and my group member name is Musfiqur Rahman. And we are working on Project 2, and our project title is Statistical Data Analysis on a Dataset of in Hospital Mortality Prediction. So this is our table of content and our introduction. Uh, the most intelligent species is in on Earth is the human race, and everyone finds the functioning of the human body to be an interesting and fascinating subject. How our immune system defends us, how our heart pumps blood throughout the body, how our brain receives information from every region of our body, and so on. So this is our data set, and the data set we have used was about in hospital mortality for the patient in ICU, and this is our data set, name, variable, and data type, and this is the selected variable, test, and description. And now this is the data analysis and hypothesis testing. This will explain Mushfiqur Rahman.
Mute karo. Hello, assalamu alaikum. I am Musfiqur Rahman. So my part is the hypothesis testing. So here we have a random sample of 398 represents from it's 398 patients in ICU. So here we set the null hypothesis equal to mu is equal to 70 and our alternative hypothesis mu greater than 70. So here we have a significance level of alpha which is 0.05, and here we can see that we have a formula of z, z is equal to x bar minus mu divided by variance divided by root to the power n. So here we can calculate our z value, and we can discuss about that. For the 0.05% we get about 1.64, but here we get the z value of 6.033. So here we can reject the null hypothesis because and there is evidence of to conclude that mu is equal to greater than 70. So can you scroll for the regression test? As we said, for a scatter plot, we use the diastolic blood pressure from and the respiratory rate from the random sample of 398 patients of ICU for our regression test. Can you scroll down? So here we use the sample of our ICU results. Here y is equal to 52.6058 plus 0.2918x. So here we use the our formula r is equal to summation of y minus y bar whole square divided by summation of y minus y bar whole square. So here we can find the value is equal to 0.0113. So it scroll up here it indicates that 1.113% among the 398 patients that has their diastolic blood pressure is related to their respiratory rate. Okay, scroll down. For the correlation test, here we again set our hypothesis value, null hypothesis equal to 0, and alternative hypothesis equal to not equal to 0, which is linear correlation exists. So here we again use our scatter plot using our formula. So our test 6 is equal to if t is equal to minus 1.96 or t greater than 1.96, then each I mean null hypothesis will be rejected, otherwise we fail to reject. Scroll down please. uh, Little up. Okay. From the scatter plot, we can see that the points are spread around the graph, but sloping a bit downwards, which denotes there is a weak negative relationship between heart rate and systolic blood pressure. Since both variables are ratio type data, the sample coefficient correlation is calculated by using Pearson technique. We got r is equal to minus 0.15. So we can say that there is no relationship between the heart rate and systolic blood pressure. So now the chi-square test independence. Here we said the n is equal to 398 and alpha is equal to 0.05, and as far as null hypothesis is equal to the general man chances getting affected by diabetics, and the alternative hypothesis the man don't have diabetics. So here is our value data. set value, and we should our formula is f is equal to fcf into fr divided by n. Scroll down, please. So using this formula we can get the percentage our value that is we fail to reject the null hypothesis. So that means there is no not sufficient evidence to support the null hypothesis. Conclusion তুই ক।
So, in conclusion, we can say since we are not medical students, we are unable to learn about all the linked variables that make up the human body. However, using hypothesis testing, we are able to determine that the mean age of the patient in the ICU in our dataset is larger than 70. Regression analysis have also shown that this individual diastolic blood pressure dependence on res- respiratory rate is minimal but not non-existent. Finally, we can say that throughout Project 2's entire process, we learned how to present a hypothesis and test it to determine whether it is correct or not, how to determine the relation between two variables using correlation and regression, and how to determine whether a variable is independent or not using the chi-square independence test. So this is the raw data type and our source code. So that's it. Thank you very much.
So thank you, that's our project.